What we're going to do is we're going to go over the solar nebula theory and review some of the things that we talked about in class so that you can fill out the note in case you've lost it. Okay, so solar nebula theory is our process to explain how the solar system formed. And we need this so that we can explain some of the basic properties of our solar system, which include the fact that all the planets orbit the sun in the same direction. They are all on the same general plane, and what we can see here in the diagram, if we look at our inner planets, their planes are relatively flat, and only a few of the outer planets are skewed, but it's not very much. And the fact that we have rocky planets close to the sun, and we have gas giants further out. Okay. Other aspects that we could also look to explain with our theory is the fact that they all generally rotate in the same direction on their axes. The fact that we have rings and asteroid belts, satellites, and moons. Now, solar nebula theory postulates that planetary systems form from a nebula, similar to how a star does. When a star forms from a nebula, most of the hydrogen and other gases collect in a center for the protostar. But at other points throughout the solar system, we have other material gather, and this forms our planets. Okay. So the nebula starts to rotate. The vast majority of the material goes to the center due to gravity and forms a star. But at other points, we have material gather that allows us to form the planets. Our inner planets lost most of their gases because once the protostar ignited and started producing energy, it also produced solar winds, and that with the heat caused the inner planets to push most of the gases or lose most of the gases out. And this is particularly evident when we look at Mercury, because it being the closest planet to the sun, it's completely lost its atmosphere. These other gases are pushed out due to the solar winds, and they're intercepted mainly by the first gas giant that we have, Jupiter, and that's why Jupiter is so large. Okay? But at the same time, the attraction of gravity brings in other material, the rocky material, and this is accumulated to help the inner planets gather mass so that they can become larger. Okay. The solar nebula theory is the theory that we're going with right now because it allows us to explain key things. The fact that all the planets orbit in the same direction is because when nebula started to rotate, all of the material in the nebula rotated in the same direction prior to the planets forming. And so all of my gases and dust particles rotated and then started to gather. And so they just kept their momentum. They kept their direction of travel once they started to form. As the material starts to rotate, gravity and other material attracts it down, and that's what helps to decrease the thickness of our solar system and other solar systems. And that's why solar systems tend to be relatively flat compared to their X and Y coordinates. Okay. Also, the material, as it's rotating, would cause it to start to spin in the same direction on its axis. Okay. And it helps to explain our terrestrial planets. Now, some of the other reasons why we believe that the solar nebula theory is an accurate model is that we've seen other planetary systems now, thanks to the Hubble telescope and other telescopes, at various stages of this, and also it follows computer models.